Hello, everybody. Welcome to Fonts and Text Rendering. Going to be a very exciting embedded UI live session this week. We're going to try something a little bit different. Instead of just me up at the whiteboard talking, I've invited a guest
We're going to try something
speaker.
a little bit different.
Oh my goodness! Let me handle that feedback.
Yes, we're going to try.
There we go. That's a little bit better. I don't need to hear myself speaking twice. So as I was saying, this week we've got a guest speaker and we're trying something new. So there's always going to be glitches. I've invited my colleague and friend Rodney Dowdle to come in and talk. Rodney is the product architect here at Crank Software and responsible for the storyboard product. And welcome to our embedded UI live session, Rod.
Hey, I'm happy to be here. Thanks for having me, Thomas.
Super. I almost had you twice there.
Yeah.
So last week we talked about the nature of embedded images and how selecting the right image format can have a big impact on how you build your embedded UI, both from a performance perspective, but also what you can actually fit in the resources that you have in terms of RAM and flash. One of the things that you had kind of remarked on is the fact that there's a lot of similarities between fonts and images. And I was just wondering maybe if you could talk a little bit about what that means.
Yeah, so if you think about a string that's being rendered to a computer screen, that string is just a collection of glyphs. That's the technical term for them, but you can think of them as like mini images.
And so those mini images, are they actually encoded together as the same way I'd see as a PNG, or how are they actually packed together?
No. So in a font file, there's basically just the data that's needed to render them as a mini image at runtime.
Oh, okay. So that font file, like, is there just one font file format? Is there different types of font file formats? I know with images, we have PNGs and JPEGs and bitmaps and all sorts of different formats.
With fonts, there's a whole bunch of different types. The two main types, though, are true type fonts and open type fonts.
And so those font file formats, they actually contain the images themselves for these glyphs?
Nope, just the data. If you had to contain all the mini images themselves, the font file would be huge.
Okay, so what's in the font file then?
It's just basically the data. So when you render a font, you use a font engine, and that font engine will take the data out of the font file, construct the image at runtime, and then push it to the screen.
Okay, so when it's doing that rendering, that sounds like the same path that I kind of go through when I do the decode of like a PNG image or a bitmap image to go to the display. It sounds a little expensive. Is it that expensive?
No, because once they've rendered the image once, they'll cache it. So they cache it in memory, and then that way, the next time you need to go render that mini image again, it'll grab it and push it to the screen.
Oh, okay. So there is a cache involved. Really, again, going back to that similarity between images and fonts here, just the same way we would decode a PNG image or decode a JPEG, we'd have a local cache. Is that what you're saying? We cache those glyph images?
Yep. So once you use it once, it goes into memory, and then that way there's a lookup performed and says, okay, I have this, and it'll use it again the next time without having to go to the font file and compute that glyph data again.
Okay. So that dynamic cache then for those glyphs, where does that sit? That must be sitting in RAM. What if my system doesn't have a lot of RAM to work with? Is there a way for me to kind of still render text?
Yeah, definitely. So if you don't have a lot of RAM, what you can do is you can pre-render those glyphs, store them as what's called a bitmap image, and then draw those directly off of like flash or storage.
So a bitmap image, do you mean like, it's really like a bitmap image?
No, it's actually just the alpha data. So because you want to colorize your fonts, we just basically store the alpha values needed to sort of render that glyph on the screen or mini image on the screen.
Okay, and once you've pre-rendered that image, I'm guessing that, again, just like the image case, that can sit in Flash and doesn't require any RAM?
Exactly. Yeah, it requires no memory whatsoever at that point. We're drawing directly, an engine would draw directly from the storage device.
So if this saves me RAM, and it sounds like it's actually even saving me the computational cost of doing the glyph rendering in the first place, what's the drawback? Why wouldn't I want to do this all the time?
Size. So the issue becomes that you have to pre-render all of the glyphs that you'd want to draw during the running of your UI ahead of time. So if you have a 70-point font and a 48-point font and a 18-point font, all of those have to be pre-rendered ahead of time. And so the size gets really, really big, really, really quick.
Oh, like, so when you say really big, do you have an example of, sort of what the difference would be?
Yeah, so for a Roboto font, which is an open source font provided by Google, if you had about 3 different point sizes, you're looking at about 5.6 megabytes of storage to store that font file pre-rendered in Flash.
Wow, that's a lot of memory.
Yep.
Well, there's a lot of storage, I guess I should say. So is there a way to mitigate that? I mean, it must be that the point size also matters in that story, does it?
Yeah, so there's a couple of different ways that you can mitigate it. The first way is you can actually store less bits for the alpha map. So basically you could go 4-bit, 2-bit, 1-bit, and that'll decimate the size of what's being pushed to storage.
So if I'm decimating the bits, what does that actually mean from a practical perspective? What does it, what does it mean for, like, does it affect the quality? Obviously, if I have less bits, it sounds like I'm getting less value.
Yeah, so I can show you actually. It basically, it does reduce the crispness of your fonts. I have an image here. I'll throw it up on the screen. Just give me 1 second. So I'm sharing. Can you see my image?
I can see your image now. Yeah.
Awesome. Okay. So what this image is doing is just showing the comparison between sort of the different bit depths. Here we have over on the left-hand screen in the upper right-hand corner, you've got TTF, and that is basically, your font engine's rendering it right from the beginning, and it's putting it into memory and caching the glyph as it goes through. And then you have 8-bit, and you can see. Sorry, go ahead.
Sorry, Rod. That TTF scenario. What does TTF stand for?
Oh, true type font. Sorry. Yeah, that's the true type font scenario where you're using a font engine to actually render the font and you're caching the glyph in memory. So that's that scenario. Okay. The 8-bit, 4-bit, 2-bit, and 1-bit scenarios are the bitmap scenarios. That's where we're pre-rendering the glyph and we're going to store it in Flash. And then we're going to render it directly from the storage device. So as you can see, there's, from this image, it's a little bit hard to tell the difference in quality. So I'm just going to zoom in a little bit, just so I can sort of show you. And now if you start to look at the 1-bit, where you're starting to lose some of that crispness on your font is around any of the rounded characters like your C, your O, your Q. If you take a look at them, you can see that they're a little jaggy. And that's because in the 1-bit scenario, you've only got on or off. Am I drawing that pixel or am I not? So it makes doing circles really, really hard. Whereas in 8-bit, you've got 255 values of alpha. So you can actually basically say, you can have a nice gradient as you're going through.
Yeah, you can really see the difference between the 8-bit and the 1-bit. So I don't see any difference between the TTF and the 8-bit scenario. Is that, are they equivalent?
Yeah, pretty much. They're exactly equivalent because what a TTF does is generates an 8-bit alpha map. So when the font engine is reading that data from the font file and creating that glyph, it's actually creating an 8-bit alpha map of that glyph.
So are there certain scenarios where, because I looking at 8 to 4, I mean, I see a little bit of degradation, but I guess I see it mostly, really when we get down to the smaller text. Are there certain scenarios that are more prevalent in terms of, where you see that image quality loss?
Yeah, definitely. It really depends on your UI and what size of font you're using, what type of font you're using. So it varies based on what you want to have happen in your UI.
So there is going to be a trade-off in quality if I'm trying to get my space savings back then. If I go from 8 to 4, maybe not as much, but certainly as I go down to 2 and 1-bit, for the big space savings, I'm going to have a quality trade-off. Yeah,
pretty much. And so there's another way, as I had said, there's another way we can go about this, that you can actually reduce the font as well. So fonts come with a lot of characters in them, a lot of glyphs in them to begin with. Say you don't need all those. Like if you were making a thermostat, right, and you only needed 0 to 9 for your really large font, you could actually just strip every other glyph out of that font, and then that way it would make the font a lot smaller, and you'd only have to render those 9 characters, for example.
So I guess the reason that we pre-render all the characters in the first place in the, kind of the pre-generated bitmap scenario is because we don't know what kind of text we might be dealing with.
Exactly.
Right?
Yeah. If you have a dynamic UI where you're going to be changing a lot of text or changing the point size, we have to pre-render those ahead of time because, the engine's not going to know what it's going to need while it's running.
Okay. But if I have a fixed scenario, let's say that the text that I'm designing with is known in advance, then what I could use is I could use this font decimating technique to just generate the content for the glyphs and the characters that I'm interested in.
Yep, totally. There's an open source tool like Font Forge that you could use, for example. They'll allow you to go through and modify the font, create your own font, and take out what you don't need.
Huh. Wow. So that sounds good. Now, I know with images, we have these scenarios where we can kind of do this hybrid approach of mixing and matching. Is that something that typically happens with fonts and text as well?
Other solutions may be able to do that. For our solution, Storyboard, we do not mix and match. And we do that because it just allows us a simpler path, a more optimized path for rendering the font glyphs.
Well, speaking of optimization, so are bitmap fonts much faster than rendering through an engine?
Yes, because there's not that pre-computed stage, the load time is a lot quicker, and also the lookup is a little bit faster as well.
Oh, okay. So lots of considerations here, lots of things to think about in terms of, sort of the nature of the UI that I'm building, the type of text that I have, how much resources I have available to me. Is there kind of a quick summary or quick rule of thumb that, you might give to someone in terms of, what they're looking at in terms of when they should go with a font engine path and when they might want to go with pre-generated bitmaps?
Yeah, so a quick rule of thumb is do you have more flash or more RAM? If you have more RAM, you probably want to go with a font engine scenario. If you have more flash, then maybe you want to go with your pre-computed bitmap scenario. But the other consideration is, what is your UI doing? Is it going to be a lot of dynamic fonts, a lot of dynamic sizes? If that's the case, then the font engine approach is probably your better approach. But if you have a lot of static text, up front what you're going to be doing, then the bitmap case may be the way you want to go.
And just so that people have kind of a sense of the magnitude of the numbers that we're talking about, I know you'd mentioned some numbers around the Roboto font. Do you have something? I know last week when we were doing the image session, we used the storyboard's metrics view to show, sort of what the profile looked like in different scenarios. Do you have something like that for fonts in storyboard as well?
Yeah, I can show you that. Just hold on one second. I'll share my screen again. So can you see my screen this time?
Yeah, no, that looks great.
Okay, so I'll just walk through this. So this is our metrics view. The designer metrics view will present the font metrics as well for your UI. So on the left-hand side, what we've got is the true type scenario where the free type font engine is going to be used to render your fonts. And you can see that there's a memory cost associated with that, and there's a storage cost. The size of the file is 156 kilobytes, so you're going to have to store that. And then to load that into memory is going to take at least 138 kilobytes. Now I say at least because when we're in Storyboard Designer, we're not sure how the free type font engine is going to actually cache your glyphs. It does that management on its own, so the memory will fluctuate as you're going through your UI.
Can you put a cap on that? Is there a way to put a cap on those resources used?
Yeah, so there's a resource limit that you can say only consume so much RAM for my cache, and when you specify that, it won't grow unbounded.
Okay, so that's your trade-off between the CPU, using additional CPU to constantly re-render those glyphs and caching it so that you've got it ready to go.
Yeah, exactly. The second metric view you can see is the 8-bit scenario where we're going to pre-render the fonts as in an 8-bit alpha map. So we're basically going to use 5.63 megabytes of storage space, but no RAM in this case. And that's for 3 point sizes. The image that I showed before where it had 48, 32, and 16. So 3 font sizes, and there's about 878 glyphs in the Roboto font. So you're looking at 5 megabytes to store that.
So each glyph each glyph in the font is stored at those 3 different point sizes, and the bigger the point size, the bigger the storage cost. Is that, do I have that
Exactly.
right?
Yeah,
Okay.
exactly. Yeah. So the larger you go, so if I had a 70 in there, that you'd see an even bigger size there. But for
Yeah.
those 3 point sizes, we're at about 5 megabytes. And then in the last scenario, what I did is I took FontForge and I took the Roboto font and I stripped out everything except for, the ASCII characters. So about roughly 93 glyphs. I took out everything except for about 93 glyphs, and we can see that the size for the same point sizes, the storage size is now 537 kilobytes. So it drops significantly.
Yeah, that is a huge drop. So, I mean, that if I look at that compared to, the original TTF cost, we're not far off of the original cost. And
Nope.
I've got a fully deterministic system where I know exactly, sort of what characters are going to be rendered and what that cost is, and I'm not consuming any RAM. Is that right?
Yeah, that's 100% correct. And so, in that scenario, you've gotten almost the same storage cost, no RAM, and you're basically pre-rendering your fonts ahead of time.
And if I read the titles right on this, that's at the 8-bit quality level. So that's the same quality level as what we would have been doing with the TTF rendering. Is that right?
Exactly. Yeah. Yeah. No degradation in the rendering quality of the font itself.
So is it fair to say that if the quality of the 4-bit scenario was, was reasonable to me, I was looking at it and I could see that, for the point sizes I had and for the text I had, it didn't degrade the visual presentation. I could chop that number in half again.
Yep. Yeah. It's simple math at that point. You just divide by 2. So
wow. So that would actually put us well below the original footprint.
Yep. Yeah, definitely. Yeah. I'm gonna stop sharing my screen here at this point. So.
Wow. Well, that was actually that was very insightful, Rod. Thanks a lot for sharing that. I guess from my point of view, sort of one of the questions I would have is, sort of if I have dynamic text, what do I know? What do I know about, sort of my capabilities of caching that downstream? And that's probably the point where I would want to go to the engine route. Is that right? Like if I had internationalized languages, I had a variety of fonts, I had a lot of dynamic behavior in my UI, and I couldn't pre-render it, then I guess I'm stuck with this notion of having to use a font engine.
Yeah, and that's probably your best approach at that point.
Okay, and so in that point, I want to use the cache attributes to limit the amount of RAM so that I can still fit in my small embedded devices.
Yep.
Perfect.
That's the way to go.
Perfect. Super. Well, do you have anything else? That was, sort of really interesting. Anything else that you might want to share on the topic?
None at this time. No, I think I'm good.
I like the reporting that Storyboard's giving me in terms of, kind of being able to say, here's my image costs and choices there. And now I can do the same thing with my font and the font costs. And I can see exactly, sort of how I balance that resource usage of how much RAM I'm using and how much flash I'm using. Really, really great stuff. I'm just going to take a look and see. We have some questions over here in our YouTube Live. So while I've got you, sort of still here, let me go and take a look. Looks like we have a question. Someone's asking, do certain fonts or graphics prefer one method of rendering over others? Does it not matter? So let me think about what that, kind of interpret that a little bit. I'm thinking, in terms of maybe we're talking about different ways of rendering, different types of rendering technologies, OpenGL versus software rendering, perhaps. Or, I guess you had said that the font contains instructions on how to create the glyph. Are there certain rendering technologies that we can take advantage of those instructions and, sort of somehow incorporate them directly to the engine?
So our engine, for example, it's in the OpenGL case, we will actually cache the glyphs in a texture, so we're able to look them up there, as opposed to having to rely on the free type glyph cache in the software case. That's just to reduce the amount of memory in the software case, whereas in OpenGL, because we have the texture already, we just use it so that we don't have to continue to create and destroy that texture. So in that case, OpenGL is going to be a little bit more favorable towards using the font engine scenario, just because that way we will have that glyph in a texture, and that's the data format that OpenGL is kind of expecting its images to be in. So that makes things a little bit smoother in the OpenGL case. In the software case, you're kind of either or. You're basically going to get the benefits that we talked about in the software case using the free type font engine. You've got this dynamic font scenario. That'd be the best case to go. And then if you know your fonts ahead of time and you want to go with a more static font scenario, then that will work as well with the software rendering.
What about 16-bit versus 32-bit displays? I know when we were talking about overall memory consumption, we said, there's different image formats for your final display. Does that play any role here?
Not really, because the image itself is actually just an alpha map, right? So it's that 8-bit, 4-bit, 2-bit. So that conversion, we're going to do that on the fly anyway, as the engine's drawing that glyph. So it doesn't really come into play.
And that's because we need to colorize. Obviously, if I want a red, green, and blue font or text, I'm not going to have 3 different copies of those glyphs. I only keep that one copy.
Exactly. And we're going to calculate that color value as we're going through for that individual pixel. So the 16-bit or 24-bit or 32-bit doesn't matter.
Great. Looks like there's a very storyboard specific question here asking about, do you support custom fonts or only certain font types? Maybe you could speak to that. What is when we're pre-generating the fonts? I mean, what are we doing there? Are those pre-generated fonts a custom font type, or are they something different?
No, they're not a custom font type. It's designer will open the font file up, read the glyph data out of it, render it into an image, and then push that out as a bitmap font. So it's not really custom at that point. The input doesn't have to be custom, or isn't custom. The output is just a bitmap image type of the alpha map data for that font, right? So that output is specific to our tooling, our engine, but the input can be a wide variety of anything that designer supports. So true type, open type,
And if I use one of these font tools, the same font tools that I use for eliminating glyphs, like deleting is easy. I can do that in Photoshop really good. I can't create an image, but I can delete stuff.
Yeah.
Is it the same sort of thing? If I wanted to create my own custom font, can these tools let me do it by, I guess, either drawing the font out or importing, kind of other assets?
Yeah. So you can pull things in, put them into the font file. A typical scenario is emojis, for example. You can make an emoji font file, and then basically push that out as either a true type font that the font engine will understand, or as pre-rendered bitmaps.
Okay. So if I could do emoji, I guess I could also do like icons or some sort of vector content too, right?
Yeah, totally. If you needed to have something that you want to have dynamic coloring, and like you said, an icon that you want to have the ability to make green or red because there's an alert or an okay situation, you could totally go that route and make that a font file and then color it that way.
Huh. Neat. Well, it sounds pretty flexible. It sounds like really, fonts do kind of come at that intersection of kind of not just being used for text, but also, being able to, be used for some of my image design elements inside my UI.
Yeah.
Perfect. Well, that sounds great. Thank you very much for your time, Rod. It was a pleasure having you on, and I'm hoping we can do this again. I like this interview format.
Sure, no problem. Anytime. You know where to find me.
I'm going to say thank you also to all of our listeners. We're going to be coming back in 2 weeks, and we're going to be shifting direction a little bit. We're going to be talking about more of the environmental considerations for your embedded UI, how you choose task priorities. We're going to talk about responsiveness. We're going to talk about some of the real-time operating system considerations, what you need to do to keep your UI responsive in an environment where you may have other system activities going on. So that's our topic for next week, or next session, not next week. And that's going to lead us into, sort of staging a discussion for Crank's advanced user training seminars. And so those user seminars can dive in a little bit more deeply than we can in our little live sessions here. And they're an hour long. And so we're going to be talking about scrolling and content manipulation in the June seminar. So hopefully you can join us for that. Thank you, everybody.